Hello and welcome to the lecture series of chapter number 1 that is gravitation. आज के इस वीडियो लेक्चर में हम gravitation के बेसिक कंसेप्ट को डिस्कस करेंगे. We'll try to understand the concept of gravity using some examples, and in the later part of the video we will look at what is circular motion and centripetal force. I hope you enjoy this video, so without wasting any more time, we'll start with the lecture. Consider a scenario. If I say that this is the surface of the earth, I say that this is the surface of the earth and there's an object which is at a height h from the surface of the earth. You need to make sure that we neglect any kind of resistive force, for example, air resistance. I will neglect air resistance, wind, and any kind of resistive force for this particular example. Now, in this situation, if I release this object from this particular height, what do you expect? What will happen to this? Of course, your answer will be that this object will fall vertically downwards towards the surface of the earth. Correct? There is no other possibility. We cannot say that the object will fly off in the horizontal direction or it will fall to the earth at an angle like this. It will always fall vertically downwards. So what is the answer? What is the reason why the object falls only vertically downwards, not in any other direction? So the answer to this query was given by this person who is Sir Isaac Newton. He was a physicist and a mathematician. There is a very famous story, you might have heard this. Isaac Newton was sitting under an apple tree and he observes that an apple falls vertically downwards. So he was interested in knowing the fact why did this apple fall vertically downwards and not in any other direction. See, Newton did a great job. He thought out of the box because people before him just accepted the fact that objects fall vertically downwards, but no one could find the reason for this. So Newton, after much thought, he concluded that the reason why this apple falls vertically downward is the fact that Earth might have exerted an attractive force which pulled this apple towards its center. If this is the Earth and if I mark this as the center of the Earth, so when this apple was detached from its branch, at this moment, the Earth exerted an attractive force which pulled this apple towards its center. Quite interesting and acceptable, right? But after this, the interesting part is Newton had some questions. He was more interested in knowing that if objects at different heights experience this attractive force, is it possible that the objects which are at greater heights, do they experience the same force? When I say objects at greater height, I am trying to talk about moons and other planets. So Newton tried to understand and he later ended up with the law which is also known as universal law of gravitation, जो हम इस चैप्टर के upcoming videos में discuss करेंगे. Newton concluded that this attractive force is a universal force. Newton termed this attractive force as gravitational force. You need to remember, Newton termed this attractive force as gravitational force. You need to remember that this force is a weak force. This force is a weak force, but this force is a universal force. Students get confused and they assume that gravity or gravitational force is bound to Earth. It is not the case. Gravitation is available, it exists all over the universe. But if I talk about Earth, we use the word gravity. I hope this is clear to you. I hope the reason why objects fall vertically downward is clear to you. So without wasting much time, we'll move on to the next topic, that is circular motion. Now, to understand circular motion, I'll give you a simple definition. The motion of a particle along the circumference of a circle is known as circular motion. If you observe this diagram, if you observe this yellow ball, assume this to be a particle. If this particle moves along the circumference of a circle, I have drawn a circle. If this ball moves along the circumference, along the boundary of this circle, so I will say that this particle or this object performs a circular motion. I hope this is clear to you. Now you need to remember that when we talk about circular motion, we will deal with two forces. First is centripetal force and the second is centrifugal force. Now in this video we will discuss in detail about centripetal force. To understand this, let us take an example. Assume that you have a string, this yellow arrow that I have drawn. Assume that this is the string, and what you do is you attach a stone or an object at one end of the string and you hold the other end. And if you start rotating this in anti-clockwise sense, I've used the arrow. If you rotate this in anti-clockwise sense, what do you observe? The string will act as the radius of the circle, and this stone will trace out a circle. So we can say that the stone or the object performs a circular motion. I hope everything is clear to you till now. So what we can say, when this object or this stone is performing circular motion, the string is fully stretched. The string is fully stretched, which is nothing but tension along the string. This is the concept of tension along the string. Tension is nothing but a kind of force. So what do you think? When we rotate this string, we observe that this string is fully stretched and the object performs circular motion. But the moment I release the string, there will be no tension along the string, and this stone will move in outwards direction and it will fly off in any other random direction, and it will no longer perform a circular motion. So in this case, you need to observe, already we discussed that this stone is performing circular motion, and I already said if we talk about circular motion, we have two forces, centripetal and centrifugal force. So when an object performs circular motion, it is very much required that there must be a centripetal force which attracts the particle towards the center. Here if you observe this point O which I have marked, this is the center of this circle. So if you want this particle or this object to perform circular motion, what we need is this particle must experience an attractive force continuously which will pull this object towards the center, which will pull this towards the center. So this force is known as centripetal. Centripetal force की जब बात की जाएंगी, so you need to remember this word centripetal means center seeking. This word means center seeking. Always remember the centripetal force acts along the radius and towards the center. So this is very important. If there is no centripetal force, there is no possibility that an object can perform circular motion. Now, the centripetal force, the magnitude of this force is given by the formula mv square upon r. Now r is nothing but the radius. If I talk about this particular example, the length of the string will act as the radius. What is m? It is the mass of the object. It is the mass of the object performing circular motion. And what about v? V is nothing but the velocity. V is the velocity with which the object performs circular motion. Now coming back to this velocity, this is very interesting. You need to remember that if we talk about circles, if I talk about a circle, so if you want to find the direction of the particle at any instant, if I say that the particle is at this position, and if I say that the direction of the motion is anti-clockwise, so if I want to find the direction of this particle at a particular instant, so I can say that the direction is given by a tangent. The direction is given by a tangent. Now I hope you know what is a tangent. It is a line which intersects the circle exactly at one point. If I say that the particle is at this position, so if I want to find the direction of this particle at this particular instant, so I can say it is along this tangent. If I talk about this position, the direction will be given by the tangent in this direction. If the particle is at this position, again it will be along the tangent in the outwards direction. So if you observe this, the direction of the velocity of the particle performing circular motion is always tangentially outwards. You need to remember this statement. The velocity of the object performing circular motion is tangentially outwards. But if you want the object to move in circular motion, what we need to do is, if the object is trying to move in outwards direction, we need to counter attack. We need to attract the object towards the center. And this job is done by the centripetal force. I hope this is clear to you. You just need to remember that the formula of centripetal force is mv square upon r. You will use this in the later part of the chapter, and this is very important. So I hope this example is clear to you. If you want, I'll just repeat this. What we have done is, I have considered a string and we attach an object a stone at one end of the string and we hold the other end. And if you start rotating this, what we observe that this string is fully stretched, it is under tension, and tension is nothing but a force. So if you observe this, when we rotate, this object will trace out a circle like this, and we say that the object is performing circular motion. So when we talk about circular motion, we need two forces. First is centripetal and centrifugal, but we are more concerned with centripetal for now. Centripetal is nothing but center seeking force. As I said, if you look at the circular motion, at every instant, at every position, the direction of the velocity of the particle is tangentially outwards. So if you want that this object should move in a circle, so at every instant continuously we need a force which will attract the object towards the center, and this job is done by the centripetal force. This is very important. Without centripetal force there is no possibility that the object can perform circular motion. I hope this is clear to you. Just remember the formula. In the next video, we will look at Kepler's law. We will look at Kepler's law, which is very important. And after that, we will look at universal law. जो हमने अभी न्यूटन के बारे में देखा था, he looked at the apple which falls vertically downward, law of gravitation. And then he wanted to know if this gravitational force is applicable for objects at a greater height. You will learn about this in this video lecture. So I hope this is clear to you. I hope the idea of gravitation is clear to you. Circular motion and centripetal force, everything is clear to you. In the next video lecture, we will look at Kepler's law and universal law of gravitation. I hope this was helpful to you. Make sure to subscribe to my channel and hit that like button. We'll meet in the next video lecture.